All right, this is our last unit that we're going to be doing, and it is on exponentials and logarithms. We're going to talk today in this video about exponential growth, and in the next video will be exponential decay. Hopefully these two videos will be a lot of review from Algebra 1 because you've already seen exponential functions. Just a reminder from Algebra 1, when we had these tables and we had something like this, the pattern that we found was that each time we were multiplying by 3. All right, that would be an example of an exponential growth function. Right? And lots of things can model that. Money models that, populations model exponential growth. So there's lots of incentives for us to study exponential functions. So what I want you to focus on now is the format of it. So notice that I'm going to have this formula for my exponential function. And A and B are just numbers, okay? Now notice, A has to be greater than 0, okay? I'm not going to have anything with a negative there. And then B has to be greater than 1 in order for this to be a growth. Okay, then it's an exponential function. All right, exponential growth function. If it's negative, then that makes it decay. If B is smaller than 1, then it's decay, and we'll talk about that in the next video. All right, so every time you see an exponential growth, the other thing I want you to notice is that the x is in the exponent. Okay, that's why we call it exponential, is because the variable is in the exponent. Okay, so if you notice in this first example, I know this is an exponential function because the x is in the exponent. So now I'm going to try to identify my a and my b. All right, so my a value, even though it's not written, it's like 1 times that. So my a value is 1, and my b value, my base, is 2. We call the number that has the x and the exponent, that's the base. So let's just do a quick t-chart, kind of like what I did to remind you from Algebra 1. If I plug in some numbers, let's plug in, some negative numbers and some positive numbers and see what happens. So if I plug in y equals 2 to the negative 2 power. If you type that into your calculator, you're going to get 1/4 or 0.25. And if I plug in negative 1 into that exponent, you're going to get 1/2 or 0.5. And then if I plug in 0, now you should know that any number raised to the 0 power is going to be equal to 1. All right, so whether this was 2 to the 0 power or 5 to the 0 power or 372 to the 0 power, that would always equal 1 when I plug in 0. And then if I have 2 to the first power, remember anything to the first power is going to be itself. So that's going to be 2. And then if I do 2 to the second power, that's going to be 4. Okay, so that's what our table looks like. And if you look at that pattern again, this is a pattern of I'm multiplying by 2 each time. So you can see that happening each time. So that's the pattern in a table of an exponential growth. So now let's talk about the graph. If I were to graph those points, at negative 2 I was at 1/4, so real tiny. And then at negative 1, I was at 1/2, so still tiny, but a little bit bigger. At 0, I was at 1. At 1, I was at positive 2. And then 2, I was at 4. 1, 2, 3, 4. Okay, so it looks like this. It's going to look like this. Okay, so notice that it's really, really almost horizontal over here on the left side, and then it curves and then turns real sharp. Okay, so let's talk about what we're going to see in these graphs. So the first thing that we're going to notice about exponential growth is that it's always rising. So it starts off gradually rising, and then it starts rising really quick. A is always going to be the intercept. So remember before on the previous page we said A was 1 and B was 2. Well, notice that my y-intercept was at positive 1. And that will always occur. So if my A value was 5, then I know this function would be crossing at positive 5 instead of at 1. Okay, also, when x equals 1, my y value is going to be A times B. So that's just kind of a shortcut. I don't know if you realize that in our table, that when x was 1, here, let me go back to that. X was 1, then all I had to do was multiply my A and B together. 1 times 2 is equal to 2. And if you think about why that is, we said that anything to the first power is going to be itself. So if I do B to the first power, that's always going to be B. And then I'll be multiplying by that number in front, which is A. And then going back to why is the y-intercept always A? Well, if I do 2 to the 0 power, we said that's always 1. So if I multiply by that A power, it's just always going to be A. And you don't have to worry about that. In case you're curious about why that is why. That is always true. All right, now let's talk about domain. Domain always means x values, right? What x values can I plug in? Well, you saw that I could plug in negatives and positives. I could even plug in fractions if I wanted to. And the way I see that on the graph is that this graph goes forever to the left, and it's going to eventually go forever to the right. Even though it seems like it's not going much further to the right, it will gradually. If I kept zooming out and zooming out, it would keep going to the right forever and ever. And then if we talk about domain, we're going to talk about range. Notice that my range is always going to be y is greater than 0. So even when I was plugging in negative numbers, my answers were always positive values. And you see on the graph that it really doesn't go below right here. It doesn't go below my x-axis. So y has to be greater than 0. Do you notice that I don't say it's greater than or equal to 0? Because it's never going to touch that line. And that's that new word that we learned last unit, asymptote, right? It's that invisible line that the graph gets closer and closer to but never crosses. All right, so these exponential graphs are always going to have those asymptotes. Okay, it will always get closer and closer to that line but never touch it. Now, over here, let me get my pointer. Over here, that part of the graph, that part, it will keep going and going and going further to the right and further up. So that doesn't really have an asymptote that we have to worry about. There will not be a vertical asymptote, just a horizontal asymptote. Okay, so it's going to get flat as it gets closer to that horizontal asymptote, but it won't get real vertical. I mean, it'll look like it is, but it will never have a vertical asymptote. All right, so that's enough about the graph. So let's see if we can use our observations to make the graphing easier. That way we don't have to make a full T-chart every single time. Okay, so first thing I said, in this example, let's figure out the A and the B. The A is 4, and the B is 3. And we said that the y-intercept will always be at A. So our y-intercept has to be at positive 4. 1, 2, 3, 4. Okay, and then we said when x equals 1, the y value is always going to be A times B. So that will be 4 times 3, which is 12. So when x equals 1, it's going to be all the way up here off my chart here. So we'll call that 12. Okay? Now we also said that my range, has to be greater than 0. So I know it has to stay above that horizontal line. And so I'm going to use those 2 points and the fact that I know it's going to get closer and closer to that line to draw that graph. So you notice that I didn't have to make a big T-chart there. I just used my observations to draw that graph. Put 2 points on there and draw the graph. So let's do the same thing over here. Let's start off with the A and the B. So A is 0.5, that's the number in front. B is the base, the one with the exponent on it, which is 4. So our y-intercept is going to be our A value, which is 0.5. So it's going to be crossing at a half. And then when x equals 1, my y is going to equal A times B. So that's 0.5 times 4. So what's half of 4? That's just 2. So when x equals 1, y is 2. 1, 2. Okay. And then we know that it's not going to go below 0. So now I've got my 2 points. It's going to be really flat by the asymptote and then curve up. Okay, so again, we've graphed our exponential growth function without having to do our t-chart. So now what I want you to think about is what happens if I add or subtract. Okay, this is going to be, if you notice, this is going to look like our HK format. So I'm going to have my A times my B, but now up here in the X, I'm going to have X minus H, and then afterwards, I'm going to have a plus K. So the H and the K means that we're going to be shifting. Okay, so if I have X plus 3 in my exponent, my H value, remember, is always opposite, so my H value is negative 3. So that means it's going to shift to the left 3. Okay, so again, if I take all of this, and this is why, if we were to do our t-chart again, okay, if I plug in negative 2, well, watch what happens when I plug in negative 2. I have to do negative 2 plus 3. So this is really like doing 2 to the first power. So it's like I shifted this table up, didn't I? It's like I'm getting the values that I originally got for 2 to the 1, I'm getting right here all the way up here. All right, so this is going to be 2. All right, if I plug in negative 1, then it's going to be like 2 to the second power, which is 4. If I plug in 0, that's going to be 2 to the third, which is 8, and so on. All right, so this is going to get big really quick. So at negative 2, I'm at positive 2 already. At negative 1, I'm at 4. 1, 2, 3, 4. At 0, I'm at 8. And then at 1, I'm already off the chart. Okay, so I still have that asymptote, but what happens with that is everything got shifted over. So remember, this was originally right here at 1. That was originally where my y-intercept was. I'm going to draw in red what it originally was. That's how it originally looked. So you see how it got shifted to the left by 3 units? I can count 1, 2, 1, 2, 3. All right, so that shifted to the left 3 units. Okay, so that's what that H value does. So now let's look over here at the K value. So notice I don't have a H value in this second example, but I do have a K value. So my K value is negative 3. And what that's going to do is shift it down 3. And I'll show you why. Okay, so I'm going to erase this table. We're going to do a new table for this second example. So I'm going to use the same coordinates. And now when I plug them in, I'm going to get 2 to the negative 2. That was, remember when we plugged that in, that was 1/4. And then if I do minus 3, that would be negative 2.75. All right, and then when I plug in negative 1, that's a half minus 3, so that's negative 2.5. And then when I plug in 0, that's 1 minus 3, so that's negative 2. And then I'm going to have 2 minus 3, which is negative 1, and then 4 minus 3, which is 1. So let's plot those. So negative 2 is now down here, negative 2.75. And then negative 1 is now negative 2.5. So let me go. Let me make that negative 2.75 a little closer. There we go. And then this is negative 2.5. And then 0 is at negative 2. And 1 was at negative 1. And then 2 is at 1. So now look at what's happening. Now it's doing this. Same shape, but it shifted down 3. So now instead of having my horizontal asymptote there, it's going to be moved down. Oh, no, I want to grab that. It's going to be moved down 3 here. So it's going to stay above negative 3. So let's summarize all of that. If you add or subtract in the exponent, then the graph shifts either left or right in the opposite direction. Remember, because h is going to be opposite. So for example, when we had 2 to the x plus 3, it shifted left 3. If I had 2 to the x minus 3, it would be to the right 3. Okay, so that's what we mean by that. And then if we add or subtract after the base with the exponent, so the k value, all right, so that means that the graph shifts up or down depending on the k value. So remember when we said it was like 2 to the x minus 3, the k value was minus 3, so it went down 3. If I had 2 to the x plus 3, like that, then it would be shifted up 3. Okay? Because our k value was a plus 3. All right, so that's what I need you to remember about exponential growth.